Cool. Okay. Well, welcome to my talk, Vulkan Project Made Easy using vk-bootstrap. Well, it's good to know. Thank you. Arrow keys, do they work? Yes, they do. So who am I? Well, I already said my name, but did I? Oh, I actually don't remember. I've been using Vulkan since 2017. I was a student in university, but like that's a long time ago now, it feels like, geez. And in 2019, I joined LunarG. Since then, I've been maintaining Vulkan Loader, API dump, Vulkan info, doing SDK development, futzing around with CMake and validation layers and all sorts of things. But I've also been super active in the Vulkan Discord. A lot of you out there probably know me from that, which is cool. All that is to say is I've been around and I've been seeing people write Vulkan for quite a while. So I have to ask, has this ever happened to you? I mean, you wake up in the morning, you're just full of energy, you got 9 hours of sleep, and you're like, I'm finally going to tackle that project. I'm going to get that Vulkan render I've always dreamed of. So you head up to your computer, you open your editor, you start slamming on the keyboard, and you got an instance going. And you've selected those validation layers and created that debug messenger, and you're just off to the races. So you're like, okay, what's next? You go and you enumerate all your devices. I mean, you got all your devices, and you're like, I got to get my features. So you go and enumerate all your features. You look at all the capabilities, like, ooh, this one has more memory than that one. Okay, I'm going to go do that one. And you figure out which device I'm going to use. So you now have that physical device in hand, and you create a device with it. And of course, to create a device, you got to enumerate all the queues that are available. And then you got to pick, well, do I want graphics and compute and transfer, or just transfer and compute? Oh, what are these sparse binding queues? That's weird. Okay, I don't think I need them, but I'll keep them in mind. And you go through it, and you throughout this whole process, you've burned some time, and you've had lunch, and you took a little break to walk the dog or sit with your cat, and well, you finally get around to creating a swap chain, which first means you had to go and create a window, and that whole mess had to be figured out. And okay, to create a swap chain, you first have to know which present mode and your capabilities and your formats. And you're like, well, I want to do HDR, but do I really need? I mean, okay, whatever. Just get on with it. And unfortunately, you're starting to get to the end of the day, and you're tired. You're just out of breath from all the hammering on the keyboard. I mean, you're what, 500, 1,000 lines of code in, and this is all you have. You're just losing motivation and fast. So obviously the solution is you close your editor, you put it away, and you remember you don't start new Vulkan projects. So if this has ever happened to you, introducing vk-bootstrap. It's the abstraction that handles all that for you. It creates instances in devices really easily, selection of physical devices as a whole utility for that, and swap chain creation and recreation, which admittedly is the same thing, just again, but it's nice to have. It uses a builder pattern API, so it's a very expressive and clean call, create an object, call a bunch of functions on it, call one final function, and get your thing. It's C++ 17, very minimal dependencies. It needs Vulkan headers, as it turns out, because it's a Vulkan library. But beyond that, I mean, MIT license, it's very minimal in that regard. It's easy to build. I mean, we're one source file, 2 or 3 header files at this point. So just slap that in your build system. And it's now battle tested, as I guess I could say, because it's 4 years old and used in a lot of projects. I know vkguide.dev uses it as its, hey, let's get Vulkan started, but we don't actually want to deal with all the futzing around with boilerplate, so we'll just use this library. And so that's a really quick overview of it. But an overview is not what you came for. You came for some nice getting into the details. So I have to show the design of the API because it's the same thing every time. You have a wrapper builder object, which you call build or select on, and it returns a result with templated on a wrapper type. The result is a custom expected result type, like from other languages, that will either have your thing or an error. So you can quickly and easily figure out, did I succeed or did I fail and need to retry, or error out to the user and say, hey, I can't do that. The wrapper object is just a struct with your object in it, instance, device, swap chain. And it's very easy to get your, oh, I got a typo. It's supposed to be capital V on the VK object for the type, because that's the convention. Oh well, the VK object type, it has the handle in there. So that's the broad overview of how the API looks. Custom result type, if you're curious, it's a very simple expected like thing, ad hoc, because I'm not using C++ 23, which has it. And so, very simple API if you've seen this before. And you shouldn't ever need to know about this other than you can call value or error on it. So actually using the API is much more like this, where we are creating an instance. So we have our instance builder object. We can call a whole bunch of setup functions, setting a name, an engine name, API version, and you can either require an API version or just be like, hey, if this is available, go up to that version. But if not, it's okay. I think that's in there. There's a lot of them, so it's easy to get lost in all the different configurations. So there's a default debug messenger that will just take all of the things coming to your debug utils messenger and pipe it to stood out. You can easily sub in your own. So if you wanted to write to a file and stood out, you could do that. And once you've configured your instance how you like, you call build, and you get this instance result, which you should check for errors. And if there aren't any errors, you can get the value of. So some features of instance creation is that it automatically chooses the WSI extensions per platform. So it will enable Surface and whatever your platform specific Surface extension is for you. You don't have to think about it. If you don't want it to enable any Surface extensions, you just call set headless. So it will go into a mode where it doesn't care about surfaces, swap chains, or any of that kind of stuff. What other? Nah, there's not really anything. Okay. So with an instance handle in hand, a VKB instance object, we can move on to physical device selection, where we pass in the wrapper object, which is used to feed the rest of the next step in the boilerplate process. We can set our surface that we're going to use, because famously Vulkan, you create your instance, then create your surface, so you kind of can't just have a surface ready-made, even if it only needs the instance. You can set your minimum version. Of course, this is your device minimum version rather than your instance version. You can require various properties on it, extensions, features, in this case, different types of queue setups. There's, transfer queue, compute queue. Initially, when I designed the library, I thought I'd have way more use of the queue selection thing, but as it turns out, queue selection is kind of difficult to abstract. And so what is there, it works, but it is what it is. And once you set your requirements, you can call select. That will go in and enumerate all devices, figure out all their properties, and do the requirement checking for you. So it will go through every physical device and validate that the requirements you set are met on that physical device. And if they're not met, it will not use it. And if there are no physical devices that meet your requirements, you'll get nothing, or rather, you'll get an error saying there are no physical devices that meet your requirements. Either change your requirements or plug in a new GPU. We, of course, check the error, and we can move on to device creation, except, well, maybe you chose the wrong device type because there's integrated in physical and discrete hardware. And so if you want to specify your integrated GPU because you're trying to conserve battery, you can specify that very easily. You can also say ignore the device type. By default, vk-bootstrap does choose the discrete GPU because that seemed like a sane default. It may not be, but it's one line of code to fix that. So it's configurable. And of course, there's a lot of good features in Vulkan that you just got to enable. So you have a very easy way to set the core features, the 1.1, 1.2, 1.3. I have here the minimum version to go along with it. And extension features, you require an extension and require a feature struct. It supports arbitrary feature structs, so it doesn't require recompiling to get whatever feature struct you want, which is actually kind of nifty. Before I move on, you can choose not a single physical device, but you can say, give me all of the physical devices that match my criteria, which then you can provide to the user as a list of physical devices that the user could choose from. So you don't have to pick a single physical device if you don't want to, or you're not in a position to pick a single physical device. Okay, with all that physical device selection nonsense out of the way, we can create a device. This would be where you do additional queue enablement, and queues are complicated just because they try to abstract over a myriad of different hardware setups. So it's kind of complicated to set up in the library too. But fortunately, vk-bootstrap by default enables one queue from each queue family. So even if you don't say anything, you'll be able to get at least one queue from every capable queue family on the hardware, which I think is reasonable. Multiple queues are a nice thing to have if you know about them and can make use of them. But by default, just having a single queue from each queue family is enough to go and get started with all the different types of work there are out there. So a quick dive into what these wrapper structs look like. They're structs. They're not RAII types. They're not fancy wrappers. They do have a implicit conversion operator to the thing that they're wrapping. So here I have struct device. I don't have the code listed, but it will implicitly convert to a VK device. So you could pass this object into any Vulkan command. You can see here's all the members that were used to create it, like the physical device and the surface, where those were not inherited, but provided from the constructor that took a physical device object. And that lets it fill in all the information it needs for you to quickly to quickly get all the things you want from a device, querying queues and whatnot. And I mean, this is stuff that you really don't need, but it's there to show you have access to. Queue retrieval follows the same exact pattern, except instead of calling build or select, you have a get queue function where you pass in the queue type you want. Graphics, compute, transfer, sparse, video. I have not tested the video stuff, but I'm sure it works. But in the same way as everything else, you get an error type or a result type that could have an error. And if it fails, you don't get it. And if it succeeds, you get it. Easy as that. Swap chain creation is more of the same, but instead of setting your physical device features, you're setting your present modes and your surface formats. I mean, I have like the most basic surface or swap chain creation logic here, which is only using things that are guaranteed to work, FIFO, sRGB, REG, AA, non-linear. I mean, and the last thing, which is the set old swap chain, allows you to, if you've already created a swap chain, you can provide that old swap chain into it and, leapfrog it as you create new swap chains when old ones go and expire. So you get that nice memory reuse. And I mean, building a new swap chain is almost the same as building a swap chain from an existing one. It's that one parameter. So you just keep this swap chain builder object around instead of throwing it away. And you don't have to go through all the work of setting it up. You just say set old swap chain, build, and now you have a new swap chain. So we've gone through all those examples of code that you can call, but like a most basic usage of vk-bootstrap comes to like, 50, 60 lines of code, including error handling, and more complex things might be 100 lines, but it's very easy to just take and get going with Vulkan because it does all the boilerplate for you that took 500 lines. I mean, checking if a surface matches a physical device with the required formats and extension. I mean, it's a lot of just boilerplate because the fun stuff is, that's not it. The fun stuff is all the stuff after the boilerplate, like debugging device lost errors and banging your head against the wall while the screen is black for hours. Has that happened to anyone else? Okay. So when you do get on with Vulkan, you just grab the handles out of the structs because they're dumb RAI structs. because Vulkan Bootstrap, vk-bootstrap, it's not a whole framework. It's not there to do everything for you that you could do. It's there to do what it does and get out of the way and let you do what you want and how you want to do it. The interesting Vulkan code is how it is interesting, and that's tautological, but the design of vk-bootstrap is not to get in your way of writing that interesting Vulkan code. My opinions are mine, and they're going to be solely focused on vk-bootstrap and not try to infect your desires and designs. All good things must come to an end, and you got to clean up after yourself like your mom taught you to. So here's a handful of cleanup functions you call: destroy your swap chain, device, surface, instance. You can use the wrappers to make it a one-line code. You could pull the handle out of it and do that yourself. Either way works. A smattering of other features that I may have touched on already. Debug callback, yeah, I said that. Headless contexts. Yeah, the headless context is probably the most impactful switch in the whole thing because it changes all of the defaults from make sure surfaces work and make sure the surface extensions work and all of that checking, and it just turns it off. Some people don't need it, shouldn't have the impact from it. Getting all the physical devices which are suitable, i.e. get a list of physical devices that meet your requirements. I did say that. Yeah. I went through and cannibalized this own slide by just talking about it on other slides. Yeah, if you want to create optional features, you can enable them on the device wrapper. So when you pick a physical device, you're saying, these are my hard requirements. I must support these. Sometimes you have optional things where you're like, hey, if this is available, I'd love it to be enabled, but it's not a necessity. I designed it to be done at the device level, meaning after you've selected your physical device, on that physical device, you say enable optional feature. And the reason is optional features, an application absolutely needs to know whether that optional feature is true or false or enabled or not enabled, supported or not. And so it does it per optional feature. You call a single function, hey, enable this extension if available, and it returns true if it's available or false if it isn't. So your code can go, I don't have this optional feature, I won't enable it, and cause all sorts, because if you don't, you cause all sorts of validation bugs and probably crashes too. Something I didn't mention for sure was the function pointer tables. So best usage guide of Vulkan says you should load all your device function pointers. vk-bootstrap offers a utility that just returns a table of all of those function pointers to you. One line of code to get the optimal function pointers that point into the driver. It's very convenient and very nice to have. It's like Vulk, but in this library. So if you're using Vulk or the Vulkan HPP utility, you don't need to worry about it. And so integration, if I've convinced you, then you're now wondering, how do I get it into my project? With CMake and fetch content, it's this. You include fetch content, declare it, set the address, set your tag if you want, and then make available. Now you have vk-bootstrap in your project. That easy. But what if fetch content isn't your thing and you'd rather use Git submodules because you have some ideologic preference for them just fine? That's fine too. It works just the same. If you use VC package, it's in VC package. If you use Conan, it's in Conan. So all of your pretty standard C++ package acquisition methods are supported and available. Okay, there we go. And if CMake isn't your thing because reasons that I don't need to know, just compile it yourself. It's a couple of header files in a C++ file. It doesn't require any special flags other than, I think, linking in DL libs, which is pretty standard for most applications anyway. I have a friend who said, I love your library. I hate CMake. I'm going to write the pre-make code for it. And I'm like, cool. Well, yeah, computer's saying, no, you must talk more about not CMake and all of that jazz. Anyways, it's an open source project. I wrote it as why am I writing the same code 4, 5, 6 times every time I start a new project? Is everyone else doing that too? And the consensus was kinda, yeah. So what if there was a library that just did that and got rid of that for most of the ecosystem? Well, that's what it was. In 2020, I started it, and within a couple of months, I had a prototype and asked people to start using it and getting their feedback. Um, I wanted a library that was get it done and get out of the way so that you could do all the fun stuff in Vulkan. I tried to make the library a easy to use right, hard to use wrong, both in the C++ aspect. That's why there's the result type where you don't just get a thing and then you have to manually check for an error. It's like, no, if you have a thing and it's an error, you get an assertion that it failed to make it. Or if you get an assertion if you try to access it without error checking. And similarly with Vulkan, there's a lot of ways to use the API wrong. I tried to make that as hard to do in the normal pass. I mean, you can always use Vulkan wrong. I mean, that's what's fun about validation layers, just making them find all the new interesting ways to yell at me. No, I already said that. And since 2020, I've been updating it continuously. People have been adding features and bug fixes, lots and lots of bug fixes. There's been a whole buttload of contributors. I was going to put the number, and then over the weekends, 2 more contributors showed up. So it would have been out of date by the time I uploaded this. So I really do want to give a huge thank you to everyone who's contributed, even if it's just literally a spelling mistake, all the way to here's this whole giant feature. I value everyone's contribution. So a quick roadmap of things I'd like to get done as time permits. Vulkan profiles, lovely tool set. You provide a profile, and I want vk-bootstrap to just go, okay, and done. Where you give it a JSON file, and it just picks the device for you. That'd be lovely. HPP support, it's tricky to get right, but it should be doable. VKQ selection, I said earlier, it's iffy and kind of difficult to get right. I'd like to spend some time revamping that and make it more user-friendly for the more complex situations, because right now, if you want to do something complicated, it's complicated to do, which is not great. And if any of you have ideas, I'm all ears, quite literally. If you have them right now, I'll listen, but if you have them later, that's good too. And so lastly, where do you find vk-bootstrap? Well, you find it online at this address, and I hope you can screenshot it or just ask me afterwards for it. So yeah, thank you. Questions? Hmm.
Do you want to see a Rust port?
I'd love for someone to port it to Rust. I don't know Rust well enough to do that myself. If someone writes a vk-bootstrap library in Rust in their own and not just taking what I have and porting it, that's fine too. I'd love to see this style of API where it just tries to do the annoying things of Vulkan and let you get on with it. I think there's already there is at least one Rust library for not the Ash, but the Erupt bindings, which has a similar design.
Fritz abandoned it.
Oh, oh well. It happens.
I'll do it. I think this
Okay.
is great. And I think that like what you described is the same thing. Like I've had that experience so many times where I've been like, I want to do some cool things with some triangles. And then after lunch, I fall asleep from all the boilerplate. I think this is just such a tremendous idea, and there should be more stuff like this. Thanks.
Thank you.
Any other questions? Okay, we just thank our speaker again.
Okay. Thank you.